Let's look at the parallelogram. Okay, so the parallelogram, it has many properties which are very interesting. You have the opposite side parallel. So for this one, ABCD, you have the opposite side parallel. And you have the opposite side congruent. This piece equal. You also have this piece equal. This is second one. The third one is the diagonal bisect each other. These two equal, bisected by this line. And this line also bisected by this line, these two pieces equal. And at the same time, you have the angle ABC. You have the opposite angle equal. And you have this angle opposite equal. Okay, this is an important properties for the parallelogram. Now, based on the information, we will be able to do the question over here. Let's see the first one. Annie, let's see number one. Let's see, how do we do this one? We mark this guy is given 15. This is 68 degree. So AD will be how much?
AD will be 8.
Also 8. Keep going.
BC would be 15.
C is 15. And then keep going.
And then angle A would be 180 minus 68, which is 112.
Good job. And then angle B.
Angle B would be 68 degrees.
Angle C.
And angle C would be 112 degrees.
Very good. Thank you. Now, based on the information we have here, the opposite angle equal. And these two parallel, so that this is same side interior angle supplementary. Okay, opposite side equal. Very good. Let's do number 2. Stephen, let's figure out all those side lengths and angles, please.
JK is 21. KL is 29.
JK is 21, KL is 29.
29. Angle J is 127.
Angle J is 27. And then angle K.
127.
Angle
Isn't
K will be
53. And angle M is 53 degrees as well.
good. Very good. Next one. Number 4. Okay, I already upload the blank homework. You can download, print out, and fill in this. Go ahead, do this by yourself for number 4.
Do we send it to you?
Please. Next one, let's see this one. Let's see. Good. Annie, yes. So to do number 4, you will have this guy first, FED. FED here is 174. So the summation is 174. So this guy here is going to be 63. And after you get this guy to be 63, and then CDE is here. You want to get CDE. The CDE is going to be supplementary to this 174. So you get CDE is 180 minus 134, which give you a 46. After you finish here, and then you get ECD. ECD is alternate interior angle with this 71. So this guy is 71. And then the last one is DFE. DFE is right here. You can do this guy here. So the guy here is 21. And then you can get this guy supplementary to here. So you have this total is 134, and then this guy is same as this, which is 46. Total is 46, so this is 25. Okay. Next, let's do something more complicated. Let's start writing from this one here. Williams, can you unmute yourself? Let's do this one together. This question here is GHF. The GHF is this. This is 34 degree. Okay? GHF is 34 degree. So if this is 34, we immediately say this is 34. Look, this two angle is called alternate interior angle. Okay? And yeah, when you have this part, we can see what else was given. HJF. HJF total here is 124, right?
Yeah.
Given this is 124. And with this 124 for the parallelogram, these two angles are called the same side interior angle. They are supplementary to each other. What's this angle? How much will be here? $80 minus 124 become
56.
56. Very good. This is 56. This is 56. This is 34. How much is this small angle?
22.
This guy is going to be 22. Then we will be able to see how we can fill in here. The GFJ is 56. So we will fill in here to be 50 degree. And then FGH. FGH will be
124.
yes, opposite angle equal. So this is 124. And then next one, HFJ, we already have it, which is 34, right?
Yeah.
And next one, HKJ, HK right here. Okay, let's see how can we get this angle. And we also have another information we haven't used. FKJ, right?
Yeah.
FKJ here is given as 79. Is here. So in that way, our HKJ will be
101.
101. Very good. And then JGH. This angle is going to be Look, 79
79.
is here. Yeah, 79 is here. So we want to use 180 to minus these two. Okay.
Like 67.
So this is 180 minus 113. Very good. 67. Excellent. So JGH is 67 degree. And here is 67. FGJ. FGJ, this guy. This angle. This angle is, let's see here. We have that angle is how much? 67, right?
Yeah.
This guy, JGH is 67 degree. So this guy is also 6. Makes sense?
Yeah.
And this is 67. And then we have this angle, right? Look, this one, you missed the previous class. I want to mention about the exterior angle theorem. We want to find out the angle here. Notice that that angle plus this equals 180, correct?
Yeah.
So at the same time, this angle plus this angle is also 180, right?
Yeah.
This plus here is 180. This 2 plus this also 180. So that means this guy equals to this 2. Make sense?
Yeah.
This is called exterior angle theorem. The angle here is the exterior angle for this triangle. Since this plus here is 180, this 2 plus this also equals 180. So this equals this 2 together. Okay?
Yeah.
So we can write down 79 equals to 56 plus who?
21.
23, right?
Yeah.
So this guy is 23 degree. GJ, FGG is 23. Okay? Next one, FHJ. This angle. This angle is alternate interior for this one. So this is 22, correct?
Yeah.
GJF. GJF is right here. We have this alternate with this, yes?
Yeah.
So the 23 is here. If 23 is here, this total is 67, so this will be
44.
good. Thank you. Very good. In that way, we find out all this angle in this graph. Okay? Yeah. We given the condition, we start to mark and then go to the surrounding angles to find out the neighboring angles, and then we will be able to push forward to every question marked for here. Next, we will have the algebra combined with angles. Let's see, Angela, let's solve this one. Let's use the algebra 1 to solve this angle. This is a 2 angle given here. What we do next?
3x plus 5 plus 8x minus 12 equals 180. 11x minus 7 equals 180.
So 11x minus 7 is 180. So 11x become
187.
become
17.
very good. And then the x is not the guy we are looking for here. We are looking for the angle R. The angle R is equals to which angle here?
Angle P.
plug in.
Equals 56.
Next one. Let's see. Timothy. Look at this.
It's 4x plus 9
Hold on. KLH.
is
KLH is right here, which is
Yeah.
134.
yeah. So it's
And the given here is 4x plus 9.
mm-hmm.
If this is 4x plus 9 here, this is 25. If this is 25, this will be
4x plus 9.
Hold on, this is 25, this is also 25, right?
Yeah.
Okay, so mark this guy 25 here. And then this plus equals,
Wait, 134 plus 125. I mean,
so what's the equation? Tell me the equation.
the equation is 4x plus 9 plus 25 plus 134 equals 180. 4x plus 34 plus 134 equals 180. Four x plus 168 equals 180. 4x plus 12, 4x equals 12, and x equals to 3.
That's it. Good job, Timothy. Yeah, you improve a lot. Thank you. Next one. Let me call Sophie. Let's try this question over here. The guy here is 4x plus 6. And this is this. So that will be the same, right?
Yeah.
So here is 6x minus 11. And then ABC is right here. So what's our equation?
4x plus 6 plus 6x minus 11 is equal to 115. 10x minus 5 is equal to 115. 10x
And-
is equal to 120. X is equal to 12.
62. And then let's get the ADB. Go ahead.
6 times 12 is 72. Minus 11 is equal to 51.
Good job. Very good. Thank you. Next, this part is a key point for what we are learning today. Go ahead. Let's draw this thing on your paper. Even though you already have it, still draw this. This is something very important. We want to keep in mind of all these three methods. This is going to be with us for all the high school math. Okay, we need to use those informations. I'm going to call student. It's called, if we have the property of parallelogram, if you have the opposite side congruent, if you have this congruent to here, you have this congruent to this, then this is going to be a parallelogram. So the first method is called, if AB congruent to CD and AD congruent to BC, then this is a parallelogram. So you make the distance. You get the AB distance equals to the CD distance. Then this is, the distance formula is this. If you have the points here as x1, y1, this second point as x2, y2, x3, y3, and x4, y4. If you do the distance equal then this becomes to a parallelogram. The formula is right here. So you will do x2 minus x1 square, y2 minus y1 square. And then you do x4 minus x3 square, y4 minus y3 square. If you calculate the distance equal, you calculate this distance equal, then this is a parallelogram. This method. Now we are going to do this. See, you will be given a question like this. First, you want to draw a quadrilateral. You don't know if this quadrilateral is a parallelogram or not. You put your 4 points A, B, C, D. After you put it's A, B, C, D, and then you want to calculate the distance. Do AB first, calculate it based on the formula, and then do the CD, and do the AD, and then do the BC. Calculate the value by using the formula, using this thing, okay? Do the square difference, do the different square plus different square, then do square root, calculate this full value to check if the opposite side are equal. Go ahead, do this by yourself. Finish this, text me, okay? Or send me by email. Practice we are doing right here is called analytical geometry. This is called analytical geometry. Very good, Annie. Yeah, that's very good. So you can have the conclusion. Yeah, if you have the two opposite sides equal, this will becomes to a parallelogram. Students, if you haven't sent me your work, please. See, you miss a square root at your last step. Fill in the square root for the last one, then everything will be fine. Now, everybody get this one? You have the distance. You have the AB distance equals CD distance. Then you have AD equals to BC. So this becomes to a parallelogram. Good job, Angela. That's great. Other student, Williams. Can you send me your work, please, William? Let me give you my phone number. You can send me, okay?
Oh, I sent you my work.
Oh, you sent by email?
No, I sent by text.
Okay, I didn't receive it. Check if this number is correct. Excuse me, I didn't receive your work yet.
Oh no, I'm Tim.
Oh, Tim, yeah. I'm asking Williams. Williams, can you send me your work, please? Steven, you sent me your work already? Oh, yes.
Yeah, I sent it.
You sent? I didn't receive this.
Oh, I'm Steven. I sent.
Sophie, that's excellent. Very beautiful. That's the one. Number two, we are still going to using the same idea to do the distance to check if the distance equal for the opposite side. All right. Next one, let's call Sophie. Let's try this one. When we have PQ, when you do this, you will do given by the given order. So you draw PQRS. Otherwise, you don't know you want to do which distance. There are so many options. You can do PR, you can do QS, but you don't do that. You do PQ, you do SR. Sophie, let's do the PQ distance, please.
Parentheses, -4 minus 6 squared plus parentheses 2 minus 4 squared, which will give you 100 plus 4, which is square root of 104.
This is 100 and this is 104. Okay, now this is PQ and then let's do RS. Go ahead.
Parentheses 11 minus 2 squared plus parentheses -2 plus 3 squared. And you get 81 plus 1, which is 8, square root of 82.
Good. Next one, let's do PS.
Parentheses -4 minus 2 squared plus parentheses 2 plus 3 squared. And you get 36 plus 25, which is square root of 61.
Good. Next one is QR. Let's do it.
Parentheses 6 minus 11 squared plus parentheses 4 plus 2 squared, which give you 25 plus 36, which is square root of 61.
Good. So you notice that the PS and QR equal, but the PQ and SR not equal. So that is not a parallelogram, okay? Because if it is a parallelogram, then the opposite side has to equal. So it is not one pair is not equal, so it's not, okay? Next one, yeah. So this is the method one. The method one is by checking the opposite side if they are congruent. This is the first method. Second method is going to be checking by opposite side parallel. We have the slope formula, Williams. The slope formula is this, correct? Do you know this slope formula?
Yeah. Yeah.
So we can do the slope calculation to check if the opposite side are parallel. Now let's do this next question. We are going to do this slope calculations. So I'm going to erase my work and we will do this one together. First, you still draw it. So you will draw by the given order, you do W, X, Y, Z. And then your WX slope, go ahead. Your WX slope, how do we calculate this?
So -4 plus 6 over -7 minus 1.
Yeah, -4 minus -6 plus 6, -7 minus 1. Okay, so this becomes to positive 2 over -8, which is -1 over 4. And then let's do when we have the WX, we don't want to compare this slope with this slope. We want to compare this slope with this guy, okay? So let's do the YZ. Go ahead, please.
So -13 plus 12, and then 5 minus 1.
Let's give us a -1 over 4, right?
Yeah.
Excellent. So this shows that they are equal. So that means this two is parallel. Next one, we want to do XY. Go ahead, please.
-6 plus 13. 1 minus 5.
So this give you a -7 over 4, right?
Yeah.
And then let's do after we have the XY, we want to do the WZ. Let's do the WZ.
-4 plus 12, and then -7 minus 1.
So this give you a -8, positive 8 over -8, which is -1, okay?
Yeah.
Now, so the thing is showing this pair is parallel, but this is not. So this is what kind of graph?
Like here, I can really hear that.
This is a trapezoid.
Yeah.
Trapezoid, they have only one pair parallel, but the other pair are not. So this is a trapezoid, not a parallelogram. Okay.
Okay.
Go ahead. Do this with this second method. Do this one all by yourself. I don't want you to write down the slope immediately. If you don't draw the full point according to this order, you don't know which slope you are looking for. So draw EFH, EFGH. So that EFGH, you know that you want to check this pair slope. Then you want to check this pair slope. Okay, draw this one according to the given order, then find the opposite side slope. This is called analytical geometry. You guys finish geometry class with me. We will learn algebra 2. In high school, we learn algebra 1 first, and then geometry, and then algebra 2. I already said algebra 2 AEC is really hard. Algebra 2 AEC, the most hardest topic is called conic sections. Then there we will learn the circles, equation, ellipse, hyperbolas, parabolas. it's different kind of geometry shape, complicated shapes with the coordinates. That's called analytical geometry. Everything we do right now is the foundation. Good job, Timothy. Yes, you do improve a lot. I do notice about your big progress. Very good. Do this number 4 slope calculation. Good job, Williams. Very good. Steve, I think something wrong. I didn't receive your email. I keep refreshing, but I didn't.
I'm sending it to the algebra one.
Yeah, I'm checking it. Check your sending box, see if the mail go out correctly. Okay, then you unmute yourself and you do with me together and just make sure you know how to do it, okay?
Yeah, I don't think it's sending.
Let's do this one here. We draw this E, F, G, H first, okay? Now let's get the slope of EF. Go ahead, please.
It's 10 minus 8 divided by 6 minus 0.
Good. Which is 2/6, which is 1/3.
Yeah.
Yeah, see, we draw, look, follow this sequence. Draw your E, F, G, H according to this order. So the first slope you want to do is EF. And then you want to do GH. Let's get the GH, please.
GH
Yeah,
is
this slope
it's 0 minus -2 divided by 2 plus 4.
is also 2/6, okay?
Yeah.
So we got this pair parallel. We know this slope equal, so they are parallel. Now let's get the FG and the EH. Go ahead.
Wait for EH.
First is FG,
It's 10 minus 0 divided by 6 minus 2.
which is 10/4, which is 5/2. Excellent. And then let's get the EH. Go ahead, please.
It's 8 minus -2 divided by 0 minus -4.
This is 10/4, yeah.
Yeah.
Right. So yeah, you have the opposite side, two pairs parallel. So this is going to be a perfect parallelogram. Okay. That makes
Okay.
sense.
Yeah.
Next one is the last method. The first two methods we are talking about is number one, you show the opposite side equal. Number two is you show the opposite side parallel. Number three is you show that the opposite side not only equal but also parallel at the same time. then you will have this as a parallelogram. So you don't need to show these two pairs parallel. You don't need to show these two parallel equal. You show this one parallel. This also equal. Then this will be a parallelogram. So let's do method 3. Method 3 is going to ask you not only checking the distance, but also checking the slope. So let's do this. Number 5. Go ahead, do by yourself. Still draw a parallelogram first. Draw your JK, JKLM. So you want to get JK distance, ML distance, and you want to get the JK slope, ML slope. If these two equal and these two slope equal, then this is also a perfect parallelogram. Go ahead and do number 5. Yeah, good job, Timothy. Very good. You prove these two opposite side. Number 1, you get their distance. Yeah. So you get the JK distance is -9 minus -5, which is +5 squared, plus -2 minus 1 parenthesis squared. So you have the JK distance. And then you have the LM distance. You have 1 minus -3, -4 minus -7. So you have this. You have these two distance. You compare them. They are equal. and then you will do the JK slope. You will do the JK slope. 1 minus -2, -5 minus -9. And then you do the LM slope. -7 minus -4, -3 minus 1. So you do this, you'll find out that the distance equal, these two lengths equal. At the same time, these two slope equal. So it's going to be a perfect parallelogram. Next, let's draw this thing on your notebook. You want to draw a quadrilateral first. A quadrilateral means you don't know if the two opposite sides are congruent or not. You don't know if they are parallel or not. So you want to draw a random quadrilateral, an irregular one. And then if this one opposite side congruent or opposite side parallel, or one opposite side congruent and parallel at the same time. So this is a special case for this quadrilateral. This is a parallelogram. Not always this guy will be a parallelogram if you have one pair of side parallel, but the other not. This is called a trapezoid. If you are a parallelogram, and then if you have all the four sides forms a 90 degree, actually, if just one angle to be 90 degrees. So here, Angela, you can unmute yourself, please. For the parallelogram, the opposite side angle equal, right? If this is 90 degree, then this will also be 90, correct?
Yes.
And this supplementary to each other, so this is also 90, yes?
Yes.
And this will be 90 also. All the four together is 360. So in a parallelogram, if you have one angle to be 90, then all of them will be 90, okay? And then for this parallelogram, if you have the four sides all congruent, you have the opposite side congruent already for the parallelogram. But if you have these two equal, then all these four will equal because this equals this. If this equals here, but this equals here, so all of these four will equal. What's this kind of shape called?
Rhombus.
Yes, this is going to be a rhombus or a diamond. And then if you are both a rectangle and a rhombus, rectangle rhombus at the same time, it's going to be a square. Make sense?
Yes.
So go ahead, draw this. This is something interesting. See if we have. Okay, so that's the properties of parallelogram. Not only that, and we can do more practice over here. Let's talk about this guy here. The question on this worksheet compared to the previous one is also, this is also very easy. Just some basic things. So we need to keep in mind also in the rectangle, there are many properties inside here. I'm going to, let me give some advanced questions. Let me finish over here. If, as what I said just now, let's go deeper about those special properties. How do we know that? Even though we know that the parallelogram has the properties saying that, say, this equals this, yeah? And then this equals this. Why we can say this is a parallelogram? It is because the definition, look, the definition of parallelogram is if you have the opposite side parallel, then this is a parallelogram. But why you think if this guy equals this guy, then this guy equals this guy? How do you prove if these two equal, then these two sides is parallel? So we want to prove. So let's go ahead. Let's do something of our old friend. Let's do either the tree diagram or the two-way columns proof. So the given condition is AB is congruent to CD, and the BC is congruent to AD. So based on this, how do we, so this is given. And then we want to prove that the AB is parallel to CD and BC. From here, how do we prove here to be true? We will use something very interesting here. The guy here is congruent to here, and the guy here is congruent to here. So look at this. This triangle is going to be congruent to this triangle. In the future, we will learn triangle congruency. So let me write down the tree diagram. The given is here. So given AB congruent to CD. Go ahead, write down this. And also given BC is congruent to AD. You have these two sides congruent. You have these two sides congruent. And at the same time, the BC, the diagonal AC equals to itself. This is called reflexive property. Okay, go ahead, write down this. In geometry, the hard part is not the calculation. It is proof parts. When you have the opposite side congruent, you have these two triangle identical. Triangle, if you say, I know the triangle three side, then it's only one shape. There's no two triangles saying they have the same three side corresponding angle equal, corresponding side equal, but it's two different kind of triangle. That's impossible. The three side already fix a typical triangle. So if you have the three side congruent, yeah, these two big triangles share the same line here. So you will have these two triangle congruent. ABC is congruent to, the A point is corresponding to C point. So it's going to be C, A to C, A to C, B to D, B to D, and C to A. So you have this triangle congruent to this triangle. When you have these two congruent, in the future, we will learn triangle congruency. This is supported by SSS. Side, 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 you fix a triangle. So side, side, side. After you have this congruent, then you will have the corresponding angle equal. So the next thing will be this angle equals to this angle. This guy BAC is congruent to ACD. From here to here is something called a CPCTC. You might say, oh my gosh, I need to know this. Look, the quickest way to remember this CPCTC is by writing down the CCC. And then in the middle is called a PT. So this is CPCTC, okay? It's called corresponding parts of congruent triangles are congruent. So these two angles equal. When you have these two angles equal, look at this. Stephen, when I have these two angles equal, do I have these two lines parallel? This two angle is called what? What kind of angle?
Exterior, I mean, alternate,
No, alternate interior angle. Okay, so you
Yeah.
have AB parallel to CD. So you have AB to CD because
alternate interior.
first, okay,
Okay.
alternate angle converse. Make sense?
Yeah.
Okay, and when these two triangles are congruent, you have these two angles congruent. At the same time, you have these two angles also congruent. Okay, so this guy here, this one not only give one conclusion, but also giving you another conclusion. This guy here is going to give you another conclusion. This. Do this. Okay. When you have these two triangle congruent, not only you have BAC equal congruent to ACD, but also you will have BCA. You will have BCA, BCA. CAD. You have BCA congruent to CAD also. So Stephen, when you have this angle right here, when you have these two angle equal, these two purple angle equal, you want to make who parallel to who?
Like lines.
These two angle equal, you have which two pairs lines parallel? And which two lines parallel?
A, B, and C, D.
No, this is corresponding to this line. You have BC parallel to AD. Look, you have this Z shape. That is this line parallel to this line. You understand?
Yeah.
So BC is parallel to AD. This is still called alternate interior angle. You understand?
Yeah.
I want you to take a look at this and I want you to truly understand. Okay. I'm going to ask you one more time. This purple angle equal give you which two pairs, which two lines parallel?
Wait, like the two purples?
Yes, with this two purple angle, which two lines parallel?
BC and AD.
Good. With this two blue angle equal, you have two lines parallel.
A, B, and C, D.
Yes, you got it. Make sense?
Yeah.
This two get this two line parallel. This two doesn't get this two line. Okay? This two is this two lines. Make sense?
Yeah.
Okay. And then when you have this side parallel, you have this side parallel. Do you see these two? Can you support that your ABCD is a parallelogram? That's the definition, right?
Yes.
So the conclusion is ABCD is a parallelogram. This is because definition of parallelogram. The definition of parallelogram is saying if you have the two opposite sides parallel. That's well, what we are proving here is the three methods we are choosing just now. Yeah, so 1, 2, 3, three methods we are showing over here. This is from the definition of parallelogram. But how do you know that this guy is equivalent to this so that it is a parallelogram? So we proved that if you know these two opposite sides congruent, then you can prove the opposite parallel. That's why it is a parallelogram. Okay, makes sense. That makes sense, right?
Yeah.
Now let's see more of this thing here. We are going to use those properties of parallelogram. So this question on that part. Timothy. Now go ahead. How do we solve the x here?
11x minus 10 plus 80 equals 180. 11x plus 70 equals 180. 11x equals 110. X equals 10.
That's it. Very good. Next one. Angela, let's do number 13.
9x plus 15 plus 6x plus 15 equals 180. So 15x plus 30 equals 180. 15x equals 150, so x equals 10.
Okay. Next one. Number 17. Annie. The guy here, the UH, that's not University of Houston. It's this is UH. And the FH is this. And this is 19. And this total is 5x minus 7. How do we set up the equation here?
It would be 5x minus 7 divided by 2 is equal to 19.
Very good, very beautiful. So 5x minus 7 equals to 19 double, right?
Yes.
Yes. Why we say these two bisect this equal? What's the reason we can say that? If this is a parallelogram. Yeah, we might think, look, did you see these two angles equal?
Yes.
Because this parallel to here, so alternate interior angle makes these two equal. And that the parallelogram, the property, this opposite side also equal, right?
Yes.
So you have here equal. And then at the same side, same time, these two angles also equal, right?
Mhm.
So these two angles also equal. So look at this triangle and this triangle. For two triangles, if you know that the guy here congruent to here, and this congruent to this, and then this side congruent to this side, we will be able to see these two triangles are congruent. When these two triangles congruent, then the angle that guy pointing to this, the angle that guy pointing to this, that means these two pieces equal. That means these two pieces equal. So you have these two triangles congruent. That's why these two parts are congruent. So this is double of this. Okay, very good. Keep going.
And then it's 5x minus 7 is equal to 38. And 5x is equal to 45. And x is equal to
Yes, very good. Thank you. Yeah, I don't see there is any harder questions over here. Look at this. This is KU. This is UM. They are bisect each other. So these two, you make this equation equal. Quite simple. Okay, there is no hard question on this worksheet. So this is a parallelogram. And next class, we will go through all these quadrilaterals. We will review all kinds of quadrilateral shapes. So we can see here, this is all kinds of quadrilaterals. Yeah, even though you will have this blank, you will have this worksheet notes. Please draw this, all the shape on your own paper. Do it very neat. Do the first column for the kite, second column for the trapezoid, third column for the parallelogram. Draw this on your own. Don't draw by hand. Get your paper, pencil, eraser, markers ready. Draw it very nice. I say this many times, geometry is a subject that if you can draw the things very neat and mark the correct condition at the correct spot, you almost can solve it. So drawing the graph nicely and mark the conditions is a basic skill for doing geometry questions. Everyone will need to send me a picture of this page. You can put the title of kite and leave it blank. You can put the trapezoid and leave it blank. In today's class, we can focus on getting the parallelogram column first. Draw the parallelogram. And then, as what we said over here, the parallelogram. Today, we already learned this several important properties, and we use those properties to prove. So first, the opposite side parallel. Second, the opposite side congruent. Third, the opposite side angle congruent. Fourth, those consecutive angle supplementary because this line parallel. Same thing for here, this two supplementary. And then last is a diagonal bisect each other. Special case for parallelogram will be a rhombus and a rectangle. So after you write down those 5 properties of parallelogram, you will do your rhombus and then rectangle. What's the reason I need you to, even though I already have this PDF, why I need you to do it on your own? If the thing I posted, that doesn't belong to you. So this, you don't have this muscle memory. To truly understand this and being able to apply, you need to have your own version of this graph. So you list these 5 properties, and then you draw this rhombus and also a rectangle. Everybody finish this part? Show me in front of the camera, let me see. Thank you, Steve. Thank you, Sophie. Thank you, Annie. Williams, Angela, Timothy, let me see your work.
I'm almost finished.
Same.
When you finish, send me a picture. Let me see what you did. So parallelogram already have so many important properties. As a rectangle, it's going to have even more. Rectangle is a special case of parallelogram. So everything that parallelogram has, rectangle will inherit those properties. But rectangle is special because all the angles here are 90 degrees. So the additional property that rectangle has is, first, 4 angles are right angles. Second, these 2 will equal. Oh, look on. This is saying if a parallelogram is not a rectangle, then if a parallelogram is not a rectangle, then these 2 lines will not equal. If a parallelogram, the 2 diagonal equal, then this must be a rectangle. You might feel curious why. Look at this. Okay, Angela, you can do this with me together. Look at here. How do we know that if these 2 are the 2 diagonal congruent, then this will be a rectangle? We still do this by triangle congruency. Number 1, these 2 opposite sides are congruent, right? Angela?
Yes. Yes.
And then these 2 big triangles share the same side of this line. Yes.
Yes.
So these 2 equal, and then this guy shares the same one, reflexive property. Then if you say these 2 equal, isn't that these 2 triangle congruent? You have this side congruent, you have this side share the same. You have this side congruent, so these 2 congruent, right?
Yes.
You have these 2 congruent. When you have these 2 congruent, then you will see this 2 angle is congruent, right?
No.
These 2 angle congruent, and then these 2 are supplementary. 2 angle congruent, 2 angle supplementary. So these 2 both will be 90 degree, right?
Yes.
If 90 here, 90 here, This is supplementary to here, so this will be 90. All of this are 90, yeah? If you have the parallelogram with odd angle 90 degrees, this is going to be a right angle. Make sense?
Yes.
I say it one more time. If your parallelogram is not a right angle, then these two diagonal will not equal. If these two diagonal equal, then this parallelogram becomes to a special right angle. Okay,
Yes.
that's interesting. Go ahead, put this on your graph.
I just sent you my pictures.
Very good. Parallel with right angle is another guy called the rhombus. The rhombus has even more additional property. Number one, the full side congruent. When you have the full side congruent, actually, when you have these two neighbor congruent, all of this will equal because the opposite side equal. If you have these two equal, then all this full equal. Diagonal are perpendicular. This diagonal is perpendicular for this rhombus. We can prove why this is true also. So let me call Williams. Let's figure out what happened to the rhombus, why the rhombus diagonal are perpendicular, okay? See, the definition of rhombus is this two-sided congruent, yes?
Yeah.
Right. You have these two congruent, and then you have the guy here. You have this opposite side angle equal, yes? See here, these two guys equal, right?
Yeah.
And these two guys equal, correct?
Yeah.
So now look at this. Look at these two triangles. Look at these two triangles. This equal because it's a rhombus.
Yeah.
This equal because the parallelogram, the diagonal bisect each other. So these two always equal. These two equal because definition of rhombus. These two equal because the diagonal bisect each other for parallelogram. And then this share the same line. So that two triangles are congruent, okay? They are identical. Then the angle here is congruent. This two summation is 180, and they are congruent, so each of them is 90 degrees. That's what's going on. Make sense?
Yeah, makes sense.
Okay, so it's saying rhombus, definition of rhombus, all these four sides equal, and based on these two congruent, you prove this both 90 degrees. At the same time, you can prove these two triangles congruent. When they are congruent, these two are same corresponding angle. So these two are equal. These two equal. Same thing for here. So the diagonal also bisect the angle. Look, I say this one more time. For a general parallelogram, that two angles equal. Here equals to here. Here equals to here. But you cannot say these two equal. For a parallelogram, these two may not equal. If this guy is a rhombus, then these two equal, like this. If this guy is not a rhombus, these two don't equal. This equals this. That equals that. But this two doesn't equal. Okay? Only if it's a rhombus, then these two guys will equal. Okay? That's rhombus. And then the last special case is going to be the square. Go ahead, draw this last graph here. This is a square. square. This square will be even more special. Williams. As a square, it is both a rhombus and a rectangle. So I want you to say, you see the square here, I want you to list all those properties that square could have. Go ahead, please.
Wait, wait, Alex, say it?
I want you to tell me what kind of properties does a square has?
4 congruent sides.
Look, 4 congruent sides and
For like the angles are all the same. They're all 90 degrees.
yeah, all the 4 angles 90 degree. What else?
Like the diagonals like are perpendicular.
Good. Diagonal, perpendicular, and also bisect, right?
Yeah.
Yeah. And these two parts also equal, yeah, because it's a rhombus, so these two also equal. This is 90, so one of this will be 45 degree, right?
Yeah.
This is 45, this is 45. And then we will have this kind of special right triangle. The Pythagorean theorem is going to be true. I'm going to let you tell me how do we figure out. If I say the diagonal here is x, let's see how much is x. Pythagorean theorem, x squared will be x squared become Williams. This is a, so x squared become a squared plus a squared, correct?
Yeah.
So x squared becomes to 2a squared, yes?
Yeah.
And then x will be square root 2 times a. Make sense now?
Yes.
And that's what's going on, all right? That's a special thing for the square. Go ahead. Yeah, finish this everything column here. Send me a picture, please. Everybody do your own work. Send me your work.
I think I sent it through your phone number.
Oh, yeah, now I received it. Thank you. Yeah, because I don't know why I didn't receive your email. I received your iMessage. Thank you. Steve, yeah, you get everything correct. I prefer that you can do this work based using a ruler. Okay, draw it more neat.
Oh, okay.
Yeah, after class, can you redo this kind of work on a new page? And then next class we will finish these two parts.
Yeah.
Okay. Yeah.
Okay.
In a big A4 paper. Steve. In that way, you will remember all these special properties. Listen up. Right now here, in geometry this year, I will also introduce some basic trigonometries. And the basic trigonometry will be the future's pre-calculus foundation. What kind of trigonometry we will learn in pre-calculus? So this is my class for pre-calc. In high school, we are going to remember for this everything. Every number you see on this graph, this will be remembered very clearly in high school. Don't think it's far from you. It's going to come very soon. You know, each year, look, pandemic, 3 years already passed. 3 years, yeah, that's very fast. It finished. So the thing is like this, complicated stuff is going to come to you very soon. You don't want to say you will at your 10th grade or 11th grade when your workload are very high, all kinds of AP classes. You have no time to remember all of this. I will set up foundation for you to doing this in the future. All these hard things are based on what we have learned today. Do it very neat so that you have a nice notes that you would like to take a look. If you write down very messy, in the future, you don't like to look at your. Same thing for Timothy. I need you to use a A4 paper to draw this with a ruler nicely. Okay? Yes. Yes, Annie, yes, your work is too. Do this on nice A4 paper. Finish this part, everything I listed here on the A4 paper using a ruler or markers to help you organize your work. All right, that's for today's class. In the next class, we will go through every special properties of all kinds of quadrilaterals, okay? Make sure do your homework, send me your homework, and I see you next class on Wednesday night. Thank you. Bye-bye.